Lab tests for cations. Please note this is for international GCSE only, CIE, iGCSE only. There are significant differences with UK GCSE specifications. We will cover flame tests, precipitations with dilute sodium hydroxide, then the solubility of those precipitates, precipitations with dilute ammonia and their solubility. For emphasis, this is for CIE iGCSE, not UK GCSE specifications. Flame tests for positive ions, that is cations. You may be asked to describe how to carry out the flame test. Well, you have a nichrome wire that is cleaned by dipping in hydrochloric acid and then in the flame of the Bunsen. The nichrome wire is then dipped in the metal compound and placed in the hot part of a blue Bunsen flame. There are distinctive colors for copper, barium, calcium, lithium, sodium, and potassium metal if they are present in the compound. So the metal present in the compound will produce a specific color if it's one of these 6 metals. Do you recall their colors? Pause, try and recall, come back to check and correct. Okay, so to reveal, copper 2+ is a blue-green flame, barium a light or apple green, calcium orange-red flame, lithium a red flame, sodium a yellow flame, and potassium a lilac flame. Of course, for iGCSE CIE, you are provided with a data sheet with those flame test colors. Let's move on to the precipitations with dilute sodium hydroxide. We achieve the precipitates, that is, solids formed by mixing solutions together, by adding drops of sodium hydroxide to a sample of the metal ion solution. So, for example, if we have a solution containing iron 2, that's iron 2+ ions, and we add drops of sodium hydroxide, we get a distinctively colored precipitate. That is a dark green precipitate. Can you name that precipitate? Okay, so the precipitate formed is iron 2 hydroxide. We started with iron 2, Fe2+ ions. We added hydroxide ions. We get a precipitate of iron 2 hydroxide. It has a distinctive color, dark green. However, if we add more sodium hydroxide, that precipitate is insoluble. There is no further change. So, in a very similar way, we test for iron 3 or Fe3+ ions, add drops of sodium hydroxide, obtain a precipitate. That precipitate is described as red-brown. So, add drops of sodium hydroxide, get a red-brown precipitate. The solution contains Fe3+ ions. What is the name of the red-brown precipitate? Well, iron 3 hydroxide. As with iron 2 hydroxide, it is insoluble in excess sodium hydroxide. So adding more sodium hydroxide, there is no further reaction. Copper 2, copper 2 plus ions also forms a coloured precipitate. Add drops of sodium hydroxide to a solution containing copper 2 plus ions. You get a distinctively blue precipitate. What is the name of that precipitate? Well, I hope it's obvious. Copper 2 hydroxide. As with our previous precipitates so far, there is no further reaction with excess sodium hydroxide. It is insoluble in excess. Calcium ions, calcium 2 plus ions, also form a precipitate. The complication being we form a white precipitate of course, calcium hydroxide. But we will see in the following slides there are other metal ions that form white precipitates. But the key point about calcium is that it is, as a precipitate, calcium hydroxide is insoluble in excess sodium hydroxide. Moving on to precipitates that dissolve in excess sodium hydroxide. That is, they are soluble in excess sodium hydroxide. So both ions on this slide, aluminium ions and zinc ions, form white precipitates that dissolve in excess sodium hydroxide. So with drops of dilute sodium hydroxide, we form the precipitate. In the case of aluminium, AlOH3, the aluminium hydroxide, and we indicate that it's a solid by the state symbol S. So here is our model ionic equation. Aluminium 3 plus dissolved in water, AQ, plus 3 hydroxides, AQ, gives us our precipitate, aluminium hydroxide, S for solid. Notice the balancing 3 hydroxides because we have a 3 positive metal ion. Each hydroxide is 1 minus, so to produce a neutral compound, the aluminium 3 plus ion reacts with 3 hydroxide ions. This is the ionic equation. Can you write an ionic equation for the formation of zinc hydroxide from zinc ions? Pause, write your equation, come back to check and correct when you are ready. Okay, so to reveal, the zinc is a 2 plus ion. It's a transition metal ion, so unless you know otherwise, treat it as a 2 plus ion. Therefore, it requires 2 hydroxide ions, 2 plus and 2 1 negative ions, form zinc hydroxide, ZnOH twice. State symbol S, so we've got AQ, soluble ion or ion dissolved in water, hydroxide solution, OH, AQ, and then zinc hydroxide, the solid precipitate, S. Now, both of these are white precipitates. So how do we tell the difference between the white precipitate of calcium and these two? Well, calcium, if you recall, was insoluble in excess. Both these precipitates dissolve in excess sodium hydroxide to form a colorless solution. A further example is the aqueous chromium 3 ion, Cr3+. So with drops of dilute sodium hydroxide, we get a green precipitate, of course, of chromium 3 hydroxide. In excess sodium hydroxide, so we add an excess, the precipitate dissolves to form a green solution. So at this point, it would be best to review and to summarize. So for each of the metal ions in solution, With drops of sodium hydroxide, a precipitate is formed. Can you remember the color of that precipitate? Can you recall whether it dissolves or is insoluble in excess sodium hydroxide? Pause the lesson, complete this table from memory, then resume to correct and check. So I'm going to reveal. For calcium, it's a white precipitate. It's insoluble in excess. There's no effect. Fe2+ is dark green. It's insoluble. Fe3+ is red-brown. No effect. Copper 2+ is blue. Is insoluble in excess sodium hydroxide. Chromium, however, green precipitate, it dissolves to form a green solution. Aluminium, white precipitate, dissolves to form a colorless solution, as does zinc. So you've got to distinguish between calcium and aluminium and zinc. To do so, you need to recall or understand the effect of excess sodium hydroxide. Calcium precipitates insoluble. Aluminium and zinc, the precipitates dissolve to form a colorless solution. For iGCSE, we also need to know about precipitations with dilute ammonia and solubilities in excess. A number of the metal ions form similar precipitates with similar effects of excess. For instance, calcium, although it's difficult to see any precipitate with drops of ammonia, there's a very thin white precipitate formed with excess ammonia that's insoluble. So that's quite similar to the sodium hydroxide solution observations. Fe2+, we get a dark green precipitate, insoluble in excess. Fe3+, a red-brown precipitate, again insoluble in excess. But there is a difference for copper 2+. We get a light blue precipitate, but unlike with sodium hydroxide, this precipitate dissolves in excess ammonia to form a royal blue or dark blue solution. Similarly, there's a difference with chromium 3+. An initial green precipitate, but this precipitate does not dissolve in excess ammonia. You will recall sodium hydroxide observations. The chromium 3 hydroxide dissolves in excess, but in ammonia it is insoluble. Aluminium hydroxide, again a white precipitate, but it is insoluble in excess ammonia, again contrasting with excess sodium hydroxide. Zinc 2+, a white precipitate, and this is the same as the sodium hydroxide observation, dissolves to form a colorless solution. Now, the good news is, of course, that in paper 6, you receive tables with all of this information communicated to you for you to look at. However, it's well worth being very familiar with them. So on the next slide, there is an exercise to complete. So on this slide, I'm highlighting those metal ions that behave differently with ammonia to their behavior with sodium hydroxide solution. So calcium 2+, Fe2+, Fe3+, zinc. Best to say that the observations and behaviors to ammonia and dilute sodium hydroxide are the same. Copper 2+, chromium 3+, aluminium 3+, there are differences. Can you recall the color of the precipitate formed with ammonia and the effect of adding excess ammonia? Pause, complete those missing 3 sets of observations, come back to check and correct when you are ready. Okay, so copper 2+ is a light blue, it dissolves to form a royal blue solution. Chromium 3+ forms a green precipitate that is not soluble, that is insoluble in ammonia. And aluminium again forms a white precipitate, but unlike in excess sodium hydroxide, in excess ammonia, it is insoluble. One last cation, an exceptional cation. All the other positive ions we have met are metal ions. This is a non-metal ion called the ammonium ion, 1 nitrogen, 4 hydrogens with a positive charge, NH4+. So if we have an ammonium compound, we dissolve it, we add sodium hydroxide, we warm it, we hold damp red litmus to the mouth of the tube. The damp red litmus will turn blue. That's due to the formation of ammonia. So the ammonium ion, NH4+, if it's present in the compound, the process of reacting it with sodium hydroxide and warming it produces ammonia gas. So this ammonia gas is evidence that the original compound contained the ammonium ion. Here is the ionic equation. NH4+ and OH- goes to NH3 ammonia and H2O. You might be expected to reproduce that ionic equation, so it might be worth practicing it a couple of times. Just a quick couple of problems for you to try. How would you identify the metal ion present in a sodium compound? How would you identify the metal ion present in a zinc compound? Pause, review your notes, come up with some solutions. When you're ready, check and correct. Okay, so I'm going to reveal for the sodium, the simplest thing to do, or the only thing we can do, is to clean a nichrome wire, dip in dilute hydrochloric acid, pick up a small compound sample on the end of the wire, place it in the hot part of a blue flame, obviously a Bunsen flame, and observe a strong yellow color to the flame. For the zinc ion, dissolve the compound in water and add drops of sodium hydroxide. A white precipitate would be obtained. Add excess dilute sodium hydroxide. The precipitate dissolves. However, that could still be zinc or aluminium. So a further test is needed. Add drops of ammonia to another portion of the compound solution. Again, a white precipitate is obtained. Add excess ammonia. We can distinguish between the zinc and the aluminium because the zinc dissolves. The aluminium hydroxide precipitate would be insoluble. Now, there are a lot of tests for cations. We've got the sodium hydroxide, we've got the ammonia, we've got the flame tests. You are not required to have perfect recollection of these at all. CIE iGCSE provides you with a table of all the observations. So the important thing to do is to complete past paper questions from the CIE iGCSE, that's paper 6, and refer to and become very familiar with the use of the tables of data attached to the end of the paper. Thanks for watching. I hope you feel it's improved your chemistry. Please subscribe. Please like.